This is question number 3. We're told that a sequence is defined by the recurrence relation un plus 1 equals k times un plus c. Part A says that given u0 equals 60, the initial value, and u1, the first term, equals 10, and u2, the second term, equals minus 15, form a system of equations and solve it to find k and c. So as soon as you see a system of equations, that means we're going to do simultaneous equations. So we'll try and write down 2 equations. So first of all, starting with u1. u1 is equal to k multiplied by the previous term, which is u0 plus c. u1 we already know is 10, so it's 10 equals k times u0, which we know is 60, plus c. So in other words, 10 equals k times 60 is just 60k plus c. So we have our first equation. We want to get another equation, so this time we'll start with u2. u2 equals k times the previous value, which is u1, plus c. We already know u2, we're given it, it's minus 15. So we have minus 15 equals k times u1, and u1 is 10, plus c. So that's just minus 15 equals k times 10, which is 10k, plus c. So what we have now are 2 equations, and we can use these to perform simultaneous equations to solve for k and c, our 2 unknowns. So what we'll do now is we'll write them down in a more familiar way. We have 10 equals 60k plus c. So rearranging this one, I'll make that 60k plus c equals 10. And this one, again, we'll rearrange. This one will be 10k plus c equals minus 15. We'll call this one equation A. And this one equation B. So what we want to do now is see if we can eliminate either K or C. Fortunately, we have C and C in both equations, so there's no need to multiply by anything to get the same thing. So plus C in the top and plus C in the bottom. In order to eliminate C, we must subtract. So first of all, we have 60k, subtract 10k, which gives us 50k. C, subtract C, C take away C, leaves us with nothing in there. And then finally we have 10, subtract minus 15. So we'll just show this in a little piece of working at the side. if we do this, then we avoid any mistakes. So 10, subtract, and it's minus 15. So 10 minus 15 is 10 plus 15, and 10 plus 15 is 25. So we have 50k equals 25. That means k equals 25 divided by 50, and 25 divided by 50 can be simplified to a half. So we have our value for k. We want to find c. So what we do now is we take our k value and substitute it into the first equation. So I'll clear some space. So we have equation A here. We worked out k to be a half. So substituting that in, we get 60 multiplied by a half plus c equals 10. 60 times a half is 30. So 30 plus c equals 10. And that means c equals 10 minus 30. And 10 minus 30 gives us c equals minus 20. Our second answer. Now, if we want to check that our answers for k and c are correct, then we can substitute those into equation B. So equation B was 10k plus c equals minus 15. So k was a half, so 10k equals 5, plus c, which is minus 20. So 5 add minus 20 is the same as 5 minus 20, and 5 minus 20 is in fact minus 15. So we know that our two answers are correct. So we'll write our answer, two final answers down again. Part C in, part B, I should say, so this should be B. Part B in question 3 asks us to work out U4. Now, at the beginning, we didn't have a recurrence relation we can work with because we didn't know K and C, but now we do. We have UN plus 1 equals a half times UN minus 20. Now we're asked to find U4. Now we already know U0, U1 and U2. So U3, the third term, is going to be equal to a half times the previous term, U2, which is minus 15, minus 20. A half times minus 15 is minus 7.5. Minus 20, which gives us minus 27.5. So that's our third term. We're looking for our fourth term. So U4 equals a half times the previous term, which is minus 27.5 minus 20. And if we calculate that, then we get an answer of minus 33.75. That's our final answer for U4.